Assignment 3 is out. Please read Piazza, because it's sort of, assignment 3 is not very difficult, but there's sort of some questions that I'm expecting people to ask, and it was much easier to write the assignment. I decided it was better to write the assignment that was ambiguous than you'd ask questions, and it was so wordy that you'd have to untangle all the words, because when you get a real job in the world, someone will give you a very high-level description of what you have to do, and you have to work out the details of things. So part of the assignment is you want to think about this as ask questions, and if you ask them on Piazza, then everyone sees the answer, so that's sort of fairer for everyone. Okay. Any questions about anything? Okay. So what we've been doing recently is we've been talking about planning. Then we started off with the strips representation that's defined in terms of preconditions and effects. And the strips assumptions is the features not mentioned in the effects are not affected by the action. So then we had two planners that we saw. The forward planner, which starts from the initial state. So nodes are state and arcs are actions, and it searches forward from the initial state, trying to find a node, a state where the goal is satisfied. And regression, of course, regression means going backwards, so it starts from the goal and goes backwards, searching for the initial state. Okay, are there any questions about either of these? Okay, so in order to do this, here's our example again. So let's go through some clicker questions. So again, we're going to go through. So in a regression planner, we have the sub-goal is there's no male waiting, and the location is the coffee shop. And I want to know which action, so then we have a node here, male waiting, and location equals the coffee shop. And I want to know what, in a regression planner, which actions correspond to arcs. Okay? So pick up, PAUM is pick up male, MCs move clockwise, MCCs move counterclockwise on this graph on the left here. Do you ever understand any questions about what the question means? Does anyone have need more time? Does anyone still need more time? You can have more time. Does anyone still need more time? Okay, 3, 2, 1, we'll stop. I know it's tiny today. Well, that's exciting. Good. All right, let's go through this. So what you want to do is you want to achieve male waiting or one of these other locations. So how could we achieve male waiting? We could pick up male, but if we pick up male, the location has to be the male room, right? So we could achieve this now as the last one. We can't achieve pick up male waiting because that would require pick up male, but pick up male requires the location to be the mail room, but we have to, immediately after, we have to be in the coffee shop. So we can't pick up mail as the last action. So in fact, we can't achieve this one. Sorry. Mail waiting is false. We can't achieve mail waiting is false. So we can achieve this. And the two actions that can achieve robot location as CS are move clockwise and move counterclockwise. So the answer here is D. Right? We can't pick up mail, right? Because picking up mail requires us to be in the mail room. So, right? So we can't pick up mail. Right? Because then we have to have the location, has to be the mail room, and in order to satisfy this, and the location has to be the coffee shop in order to satisfy this. Yes?
Is there any reason we can't pick up coffee before?
Well, but the rule says that we had to pick an action that achieved one of the goals. And what happens is that then you end up with a more complicated solution. You still have to achieve this, you still have to achieve this, and you have to achieve other stuff as well. So in here, the only actions we're doing are those that make progress. Okay, so we want to achieve one of these, because otherwise you get a more complicated goal you have to solve. We haven't simplified our problem. Okay, any other questions? All right. We've got lots of questions today because we want to make sure we all understand what's going on. So in a regression planner for the sub-goal, we want MW is false, the location is the coffee shop, and we also have robot has coffee. Our new node. Now which actions are possible? I think it's the same set of alternatives as last time. Does anyone need more time? Does everyone still need more time? Okay, 3, 2, 1, I'll stop. Oh, it's interesting. Lots of people said D. Lots of people said D and E. The difference between D and E is whether pick up coffee is also a possibility. Right, so we could try and achieve this, which would have pick up coffee, and the preconditions here, we still want no mail lating. The only thing we need here is the location of the coffee shop. So this is actually right, the R lock is CS. And now we have robot has coffee, and I can't remember whether robot had coffee, whether required to not holding coffee, doesn't matter. Okay, so we can do that, or we could do move counterclockwise. Okay, because we had to achieve one of these goals, and now the pick up coffee is one of the actions we're going to achieve because it makes progress, because it makes us has coffee. So I think the answer here is E. Does that make sense? All right. Next one. Now we have mail waiting is false and robot has coffee is true. So mail waiting is false and robot has coffee is true. All right, how are people going? Do people need more time? Anyone need more time? All right. So what we want to do again, we have to achieve one of these goals. What can achieve mail while not waiting? Pick up mail, right? That's the only thing that can achieve this. What can achieve robot has coffee? Pick up coffee. There aren't any other actions that achieve these. Right? So the answer is C. What? Sorry? What's the question?
If the robot is in the lab or science office and therefore can't pick up mail or coffee,
Then it's going to go to the place where it's going to pick up mail. Back here, it's going to. But this last action it's going to do is going to be either pick up coffee or pick up mail. And it's got to, if here it's got to get to the coffee shop, here's it's got to get to the mail room. Because here the location is the mail room. If this is the one, it's got to get to the mail room and also have coffee. In this one here, it's got to get to the coffee shop. But there's no point in moving. It's got to achieve one of these two goals eventually. So any other action just effectively gives us a more complicated goal to solve. So the last action is always one that achieves something. We have to achieve something. So the last action is always something to achieve something. Moving around, so in A, moving clockwise or moving anti-clockwise doesn't achieve any of these things. We still have to achieve them. So actually doing one of those actions, the last action, is not useful to us. Yes?
And in the first clicker question, how did moving clockwise and counterclockwise achieve anything?
In the previous one, oh, hang on, let's exit this. This one, it achieved R-lock, the robot's location. So the robot's location was one of the things we're trying to achieve. We're trying to get to the office and have no mail waiting. So we can move to get to the office, or we can move to pick up mail. Those are the options that we can do last. Any other questions? Yes?
wouldn't picking up mail in that case also satisfy mail waiting also?
Yeah, but you can't pick up mail and you have to be in the, if you want to pick up mail in the last step, you need to be in the mail room, but you also need to be in the coffee shop. Because you want to achieve both of them. You want to achieve mail waiting is false and the location is the coffee shop. Right? You can't pick up mail very last because then you have to, immediately before that you have to be in the mail room and you also have to be at the coffee shop.
But in that particular case, on the board, aren't we only going to pick up mail or pick up coffee?
You were going to do one of those two, yep. No, in this one here, we can't, if you want mail waiting is false. Whoops. That's not a very good pen, is it? Mail waiting is false and the location is CS. And your question is, can we do pick up mail? What has to be true here in order for that to be true? Right, the location has to be mail room. So if the location is mail room and we pick up mail, is this satisfied? No, but the location has to be coffee shop. So if this was true, if the location was the mail room and you picked up mail, then this goal is not satisfied.
But then the other example on the board, if mail is, you want mail to not be waiting, so you're going to pick up mail.
Yep.
With the robot not having coffee.
You want the robot to have coffee. The robot has to have coffee here.
But you're only picking up mail, you're not also picking up coffee.
I know, but that's why the robot has to have coffee before you pick up the mail. See, for this point here, the robot has to, because remember, everything that was not on the adlet was not achieved by this, we had to move down here. So we needed, when you're picking up mail, if you want to have no mail waiting and you want to have coffee, you have to have coffee before you pick up the mail. Right, so if you want to pick up mail, go to two different places, you want to be at a place where you've picked up the mail and you have coffee, then before you picked up the mail, you have to have coffee. Yes?
Is it legal to have a neighbor where, let's say you had, there was already no mail waiting and the robot already had coffee and you just moved clockwise, like, is that a legal action?
In this one?
Would it be possible to have is it legal to have an action where you already, mail was not waiting and the robot already had coffee and you just moved clockwise?
Well, so you could do this. So the question was if you could move clockwise and you also had mail waiting and robot has coffee, and you also had to have some other precondition here, then this is the wasted action.
But is it not legal?
Well, no, according to the regression thing, we had to achieve one of these things because we didn't want to have, because you still have to achieve it here. You still have to choose one of these things. We're not adding in wasted actions that are useless. We're only adding in useful actions. Right? This regression plan only considers useful actions, those that achieve some of the goals. Otherwise, the search space is too big. If you choose useless, this is a useless action. It doesn't achieve anything. Right? When we reduce the size of these, we want to minimize the search space. In all of these things, we're trying to minimize the search space. All right, any other questions? Oh, I have no idea what clicker question I'm up to. Hang on, we did that. We did that. Did we do this? I think so. I think we got this one next. I think we got these ones. Let's so in the regression plan, we have the sub-goal, mail waiting is false, the location is the coffee shop, and your robot has coffee. That's what we're trying to achieve. And we get the action is pick up coffee. All right, so we have mail waiting is false, the robot has coffee is true, and the location is CS. And the action we're looking at is pick up coffee. So the question is, what's in this node here? Okay, does anyone need more time? Okay. Does anyone still need more time? Okay, 3, 2, 1, we'll stop. No, 2. All right. Picking up coffee, we chose to have coffee is false. The location is the coffee shop. Because we had to be in the coffee shop, mail waiting. Okay, B is the answer in here. The other. Did the 10 people who got it wrong have any? You don't have to identify yourself. Is there any questions about that? Right, so we needed to achieve the robot has coffee is true. That's all the action pick up coffee does. It requires you to not have, according to this, it requires you to not have coffee before. So we need mail waiting to be false still. The location still have to be coffee shop, and we want to not have robot has coffee. Good. One more. This one here, note that I thought I should note here that now the action now is move clockwise, and note that A has changed from before. So now the action here is move clockwise. And this is nearly the same as the other answer, except A has changed from the previous question. I didn't want it to be... It's not trying to be tricky. So male's not waiting, the location is the coffee shop, and the robot has coffee is true, and the action is to move clockwise. If anyone doesn't know which way clockwise is, can't remember, it's just watch where the second hand goes. All right, how's everything going? Anyone need more time? We were at 104, about 5 last time. Okay, anyone still need more time? 3, 2, 1, last call. Oh, went up, good. Okay, let's stop there. C. Right, the mail room. You're going to be in the mail room, then you're going to move clockwise from the mail room to get to the coffee shop. Right, notice that it's the previous action that we're doing. Okay, so A is not sort of is a tricky thing because it's the answer is we've got to be in the mail room, then we go clockwise to get to the coffee shop. Right, so it's the previous action's got to go clockwise. So the answer here is C. Any questions about that? Okay, let's keep going here. Hopefully we're learning something from doing all these things. So we now have the sub-goal male waiting is false and robot has coffee is true, and the action is pick up coffee. And all the same solutions except C is now changed from what it was before. So how are we going? Do people need more time? Someone needs more time. All right, 3, 2, 1, I'm stopping. 104. A sizable people said C, and most people said B. What's the difference between them? Was the location, in order to pick up coffee, you have to be in the coffee shop before you do it. Okay, so the answer here is B. Notice that the prerequisite, you have to be able to pick up coffee, you have to be in the coffee shop. So the answer here is B. All right, are there any questions about that? Doesn't need location. No, it doesn't care what location it is. It doesn't care. If this is your sub-goal, it doesn't matter where, you don't care where the robot is. Right? It's going to be anywhere.
If a sub-goal doesn't include a variable, does that mean that variable is free?
It means you don't care what the variable is. I don't know what free means here. It means you don't care. It can be anything. Yes, it means you only care about whether there's male waiting and whether the robot has coffee is true. And if B is the answer here, you don't care about whether there's robot has male, and you don't care about whether Sam wants coffee and all sorts of things. Okay, so in there's a whole lot of things you just don't care about. So you don't have to consider all the things you don't care about. Okay, any questions about any of these things? Hopefully you now all understand what's going on. Much better than if I tried to tell you it all. Okay. So what we're going to do today is we're actually going, the rest of today is we're going to finish up planning. We're going to talk about how to represent a planning problem as a constraint satisfaction problem. So we've looked at sort of forward searching and backward searching, and now we're going to look at how to represent it in constraint satisfaction. Let's compare the forward and backward planners. So which is more efficient depends on the branching factor and how good our heuristics are. So that's effectively how we're going to compare different algorithms, is what your branching factor is and whether we have good heuristics or not. And you notice that when we go forwards, we're unconstrained by the goal. We can only each reach what are called reachable states, those you can actually get to, but they might be irrelevant to the goal. And when we stumble across the goal, then we've solved the problem. The goal can be a source of heuristics because we're going to try and be closer to the goal. Whereas regression planner is unconstrained by the initial state, except again as a source of heuristics. So the forward planner, right, you start from the initial state and you branch, you do this searching in a search space, and so this is the forward planner. The regression planner starts from the goal until somehow it stumbles across the goal. The regression planner starts from the goal and effectively searches all these paths into the goal. Until somehow through here it stumbles across the initial state. Okay, so one searches forward from here, one searches backwards from here. So one of the things we can do is, one of the ways of looking at the constraint satisfaction problem is that we're actually going to let you use the initial state to prune possible arcs and use the goal to prune the space. And together we're going to then somehow find this path through here. So we're going to search through from the initial state. We're going to start pruning different actions and possibilities. And from the goal we're going to start pruning them, and hopefully we're going to do better than either. So what we're going to do is we're going to do it for what's the planning horizon is the number of steps that we're going to solve this problem. And for each planning horizon, for each number of steps, we're going to construct a constraint satisfaction problem consisting of the possible actions and the features. And we're actually not going to factor. Okay. So we're going to have, so what we're going to do is we're going to choose this planning horizon k, which is the number of a variable for each state. So k is the number of steps ahead. So k is a number like 2 or 3 or 10. It's the number of time steps our plan's going to go. We're going to construct the variable for each state feature in each time. And then we're going to construct the variable for the action at each time in between. So let's have a look at the example of this. So here's my example of this. Actually, let's just do it on the board. Let's go back here. That's too complicated at the moment. So what we're going to do is we're going to do the initial time. So initially at time 0, we're going to have a variable for each feature. There's the R lock. There's a variable for R lock. There's a variable for robot has coffee. I'm going to write it at time 0. There's Sam wants coffee at time 0. There is mail waiting at time 0. And there's robot has mail at time 0. So these are all my variables at time 0. And then there's an action at time. So there's an action at time 0. And then there's the time 1 states. So there's the robot location at time 1. The robot has coffee at time 1. There's Sam wants coffee at time 1. Oh, mail waiting at time 1. And there's robot has mail at time 1. And so now we're going to, now this is the state at time 0, this is the state at time 1, and maybe we can have the same thing at time 2, right? And then we have the robot location is at time 2, etc. And there's the action at time 1. So now these have all the this is all the so now we're going to effectively, the initial state, we're going to assign something to here to all the variables. And we're going to assign the goal. Some of these are going to be constrained. So this is going to be constrained by the initial state. So this one here is all constrained. The initial state constrains this. Constrains the time 0 variables. And the goal is going to constrain these time k variables. The goal constrains the time k variables. And now what we're going to do is now we're going to construct a whole lot of constraints that are also constrained by. Now we're going to add some constraints which are constraints between different sort of constraints. So the action 1, has a whole lot of values. And if the action 1 is pick up coffee, what's the constraint that we have? So what does pick up coffee require as a precondition? So pick up coffee, that's right here. Pick up coffee has preconditions. What is it? Who remembers what it is? Make it up. What is it? Location is CS. Coffee shop, computer science. Right, so this is a constraint between the action at time 1 and the location. Right? So that's a constraint between this action and the location. So this, let's put this as pick up coffee. There's a precondition constraint between this action and the location at time 0. What about the action deliver coffee? What are its preconditions? Deliver coffee, you have to be in the right position, and it has to be Sam has coffee, right? So the robot has coffee, and the location is the office, I think. They're the preconditions for deliver coffee, right? So this provides a constraint between the robot has coffee, the location, and the action. So robot has coffee, the location, and the action. There's another constraint here, which is I'll call it the DC. So there's this constraint amongst them, right? The action cannot be DC if robot has coffee is false or the location of the office is false. What else can we do? There's pick up mail again mail has to be waiting, and the location has to be right. So pick up mail forms a constraint between where there's mail waiting and the location and the action. Okay. And this one here occurs for all of the times. So there's the same constraint across here as well. Pick up coffee is a constraint between the action at every time and the previous state. Right, so these are all the precondition constraints. Okay, questions about that? Yes. Oh, I don't know. That's just the way we made up the problem. The robot could deliver coffee whether it wants to. Maybe, I think one of the reasons maybe is because it's more modular, because someone else might come along and also Fred might be in the office as well and want coffee. We don't want to have the robot not be able to deliver coffee for Fred. We want to think about modularity in things, so we don't want to have to only deliver it for Sam, because eventually we want to do it. But it's all design about how you're going to design it. I don't know the answer to your question. It's just part of the design. I just made it up. So, any other questions? Okay. Then there are effect constraints between the state variable at time t and the action variable at time t and the state variable at time t plus 1. So let's think about one of these things. Let's think about the action that robot has coffee at time 1 is constrained by what? So where do you have robot has coffee? What does that depend on? Well, it depends on, there's a constraint between the action. What else does it depend on? Does it only depend on the action? Robot has coffee. But presumably we can't pick up coffee unless the location is. We won't be able to carry out, there's a precondition, we won't be able to carry out that action unless the precondition is this. Okay, each of these now going to Sam wants coffee. Is that affected by the action? Is it affected by anything else? Is Sam wants coffee affected by anything else? It's deliver mail. So if the action is deliver mail, then Sam wants coffee is true. Another becomes true. Sorry, it becomes false. What about mail waiting? Does it only depend on the action? Are these all? Right, so mail waiting depends on the action. And robot has mail. So this only depends on if the action is so these are the effects of it. However, when is the mail waiting? What's the rule for when is mail waiting? When is mail waiting true? What does it depend on? When's mail waiting true in this state? When's it true in this state? Or when's mail waiting? Whenever? Well, no, hang on. I'm just talking about the domain. When's mail waiting? So it depends on the action. What else does it depend on? Does it depend on the initial state? What if mail wasn't waiting initially? Right, so there's also these so-called frame constraints. Among each variable at time t, the action variable, the previous ones that don't change. So the mail waiting also has to rely on this one. So this one here, let's put another colour. So male waiting depends not only on the action, but whether male was waiting beforehand. Because this constraint says that male waiting is true if it was true beforehand and the action wasn't to pick up male. So there's this other constraint here. Robot has male if the robot had male before and the particular action that we're having. Right, so remember the strips assumption, we only wrote down the effects, but there was this implicit assumption about these so-called frame constraints. And I think they're called frame constraints because of animation, as you have this background that sort of doesn't change, and you just sort of draw in what changes. So as you go from frame to frame, you're just redrawing what actually changes. So that's why it's called the frame constraints. Okay, so now let's look at what, that's one of these things. Let's look at this one. What's this constraint look like? So male's waiting at time 1. So male waiting at time 1. At time 1. When's male waiting at time 1? When's male waiting at time 1 true? If male waiting at time 0 and what else? And pick up male is false. And the action at time 0 is not equal to pick up male. Right, that's this red one. This one. So that's 1. It's that constraint. And similarly, this one here has robot has coffee here. It says robot has coffee if it had coffee before. Well, let's do this one. Let's do 2. So what's 2? When does robot have coffee at 1? When does robot have coffee at time 1? There's a constraint amongst the action and whether it had coffee before. Is that all it depends on? So when's it true? Right, so if the robot picked up coffee, if the action is pick up coffee, then it's true. And when else is it true? When else does it have coffee? Right, or the robot has coffee at time 0. Is that right? Is this correct? And the action is not deliver coffee. Yeah. Sorry? Well, the action can't be pick up coffee if the robot had coffee. Yeah, that's held by these precondition constraints. So we sort of separated them out to make things easier. Okay, any other questions? And then there are the other 2 constraints. Oh, okay. Then there are the other 2 constraints we have. There are the initial state constraints and the goal constraints. And now what happens is that from the initial state, we're going to prune this first action to only those that are possible. Right? And now from this, and if we do carry out arc consistency from one of our actions here, right, we're going to then show that if our particular goal was to Sam wants coffee, sorry, is to be false, we're going to assign this to false, then this goal is going to constrain the previous action. So now we're going to have the action here either has to be, so when we're searching, we're either going to have Sam wants coffee here, either has to be achieved here or it has to be achieved backwards. And so this, our domain splitting is going to handle all of those things. Okay, so there's, I think, it's the same graph that I hopefully drew on the board. And these are some slides from the same different locations. You can read that yourself. We'll answer that later. So that's actually just the same examples that I've wrote on the board. I just wanted to quickly, any questions about that? I just want to quickly mention the, so in the assignment, you can actually do it all by hand if you want, but unless you're in a team of 3, then you have to do, you have to use the code if you're in a team of 3 because that's the way it's designed. But if you look at this, so this is actually just in our Python, this is actually the description, the complete description of our delivery domain. Okay, so the delivery domain we had looks essentially exactly like this. So if you look at this, then the strips thing here has preconditions and effects, move clock on. The other thing to notice is actually sort of essentially told lies before. According to the strips representation, there's not really a move clockwise because the effect of it depends on where you start from. So we actually have to have a different action for each location. So move clockwise is that there's a different action for move clockwise from each starting location because the effect depends on where it started from. So the simple way to do that is just to have a new different action for each starting location. And strip says there's just a pair of the precondition and the effect. Okay, so move clockwise from the coffee shop. The precondition is the location is the coffee shop. The effect is the location is the office. If you look at pick up coffee, the precondition here is that the location is the coffee shop. The robot has coffee is false. So this shouldn't be daunting to people who don't know Python. You can just run it, but you might have to change. One of the questions asks you to change this thing. So it should be pretty obvious how to change it. So they're the rules, and the only other 2 parts of this delivery domain are we need to know the set of all actions. And we also need to know, which is just the set of all the actions, and we also have this set of all domains. This says what are the values for all these variables. The location can be CS, office, lab, or mail room, and the other 2 are Boolean, where I just define Boolean above. Okay, so hopefully this is even people who don't necessarily know Python, hopefully this is not daunting. And please ask questions on the, please ask questions. All right, let's stop there.